this video, we'll explain how Tonic Structural detects sensitive values and how you can use Structural's recommendations to quickly replace those values and securely de-identify your data. Structural allows you to produce and manage de-identified datasets for a variety of audiences and purposes. The first step, which is critically important, is to identify all of the sensitive values to replace. Any missed values might risk non-compliance with privacy standards and frameworks such as HIPAA, GDPR, CCPA, and PCI. The Structural Workspace Sensitivity Scan searches your source data for sensitive values. Scans run automatically on a daily schedule, as well as immediately for new workspaces and updated data connections. From Privacy Hub, you can also run a manual sensitivity scan at any time. So what kinds of values does the scan identify, and how does it identify them? First, Structural identifies a set of built-in sensitivity types based on the column names and content. These include values such as names, identifiers, locations, financial information, and medical information. The built-in types reflect both personally identifiable information, PII, and protected health information, PHI. Each built-in type has a recommended generator to apply to the appropriate columns. You can also configure custom sensitivity rules to include in the structural scan. Custom sensitivity rules identify sensitive values based on a combination of data type and column name. You might use custom sensitivity rules for values that are specific to your industry or organization and that are not covered by the built-in sensitivity types. For each sensitivity rule, you specify the name and an optional description, the applicable data type, the column name criteria. This can be either a basic text match, such as starts with ABC, or regular expression. And finally, the generator preset to recommend for matching columns. You can test the rule against a workspace that you have access to. Based on the sensitivity scan, Structural assigns sensitivity types and suggests recommended generators. On Database View, the status column shows the sensitivity and indicates how confident Structural is in the identification. You can view the sensitivity type and manually set whether a column is sensitive. The Applied Generator column indicates when a column has a recommended generator and allows you to apply that generator. However, applying recommended generators one at a time could take a very long time, depending on the size of your schema. To speed up this process, Structural allows you to review and apply all of the recommendations across a workspace. On Privacy Hub, the Sensitivity Recommendations panel displays the count of columns that have recommendations and that do not yet have an applied generator. The Recommended Generators panel groups the recommendations by sensitivity type. For each column, the panel shows the confidence level and example original and replacement values. It also groups columns that can be linked, such as different parts of a mailing address. To apply the recommended generator to the checked columns in a grouping, click the Apply option. You can also enable self-consistency for the columns. For columns that were identified in error, you can choose to ignore the recommendation. To apply the recommendations to all of the checked columns, click Apply All. The sensitive columns are all now protected. You can now continue to fine-tune the configuration, for example, configure subsetting, before you generate the de-identified output dataset. To recap, the Structural Sensitivity Scan identifies sensitive values in source data. Structural has a set of built-in sensitivity types identified based on column names and content. You can also configure custom sensitivity rules to identify sensitive values by data type and column name. Each column that the scan identifies has a recommended generator. From Privacy Hub, you can apply all of the recommendations with the click of a button. And that concludes this overview of structural sensitivity detection and generator recommendations. To learn more, check out our other videos, our blogs and guides, or the structural product docs.